Alright, hello physical science friends. So this is a video that's just going to go through predicting the products of, we're going to start with just single displacement reactions. I will make another video about double, but I think single is a little bit more challenging, especially since we need to decide whether or not they will actually react. So I'm just going to go through some of these examples, kind of walk you through them. I'm going to separate this into two videos. The first one I will do the first half, so number 1 through 5, and then I will do a second video to cover the second half. So let's go ahead and get started. The first thing I'm going to want to do, always good to have a periodic table handy, so I do have one right here. So I can double check to see what it is that my oxidation numbers are. So first let's look at calcium. Calcium has a +2. Lead, this little parenthesis right here, tells us what my oxidation number is for lead. So that would be +2. And then nitrate. So I am going to double check what nitrate on my table of polyatomic ions. Nitrate is -1. So now that I know what my charges are that I'm dealing with, I can actually write out what my reactants would be. So I have calcium. Calcium is standalone. So that's going to be Ca plus lead nitrate. So lead has a charge of +2. Nitrate only has a charge of -1. So we are going to need to go ahead and have 2 of the nitrates in order to balance it out. So if I double check my polyatomic ions, I see that nitrate is NO3. So I can do NO3, and I do need 2 of them to balance out that +2 charge on lead. Now the next step is I need to see if these two things are actually going to react. So let's take a look at our activity series. See if we can get that into the frame. Now remember, with the activity series, the freestanding element, so the one that's on its own that wants to react, needs to be higher up in the activity series in order to actually do that single replacement. So we need to find calcium and we need to find lead. So here's calcium and there is lead. Calcium is definitely much higher than lead, therefore this reaction will go ahead and happen. So I'm going to go ahead and write right-handed. It'll make it a little bit neater, even though it hurts. So we can go ahead and switch. Remember, cations only switch with cations. So my calcium is going to become calcium nitrate. Calcium still has that charge of +2, just like lead did. Therefore, it needs 2 of the nitrates. And now we have lead standing on its own. Now, just to kind of let you know, it doesn't matter if you write the compound first or the freestanding one first. It doesn't matter. Either order is fine as long as they are separated by that plus sign. So now I have my reactants and I have my products. The last step is to go ahead and balance them. So I'm going to double check. I have 1 calcium on each side, I have 1 lead on each side, and I have 2 nitrates on each side. So this one is complete. I am all done. So let's move on to number 2. So for number 2, I'm going to start this the same way. So calcium is going to be +2. Hydrochloric acid, I'm actually going to write out here, is HCl. My hydrogen is going to be a +1. My chlorine is going to be a -1. So now I know all of my oxidation numbers. I can go ahead and write out my reactants. So I've got Ca plus HCl. Now the next thing I want to do is see if my calcium is going to react. So I'm going to go back to my activity series. And here's calcium. Here is hydrogen. Calcium is higher on my activity series, therefore this reaction will occur. My calcium is going to switch with my hydrogen. So calcium is going to bond with chlorine. But remember, we need to double check our oxidation numbers. So calcium is a +2, chlorine is a -1, so we are going to need this to be CaCl2. That way it balances out. And hydrogen is now going to be on its own. But remember, hydrogen is one of ours that will not be alone. It does need to be in a pair if it's freestanding. So we'll go ahead and add that subscript to that. So now we've got our products, we've got our reactants. Now we need to balance it. So I've got 1 calcium on this side, 1 calcium on that side. Hydrogen, I only have 1 on my reactant side, and I have 2 on my product side. Same with the chlorine. So I actually need to add a coefficient right there. And now I have a balanced reaction. Could go through, double check. I have the same number of atoms of each atom on both sides. So that completes number 2. So number 3, we've got nickel 2 oxide plus hydrogen. So let's go ahead and write out our reactants. Nickel, remember nickel is going to be a +2. Oxide is going to be a -2. Hydrogen will be a +1. So this is going to be just NiO. They both have an oxidation number of 2. One's positive, one's negative, so they balance out. And we need plus hydrogen. But remember, hydrogen cannot stand alone. So we're going to have H2. So now we'll go ahead and check our activity series here. And we've got nickel and hydrogen. Now remember, the one that is standing alone needs to be higher on the activity series than the one that it wants to trade places with. So in this case, our hydrogen needs to be higher than nickel. And as you see here, nickel is actually higher on the activity series than hydrogen. Therefore, this reaction would not actually occur. So we're going to put no reaction. And that's it. We're done. No balancing, nothing else. No reaction. That's it. We can go ahead and move on to number 4. So number 4, I have lead 2, so that's going to be a +2. And I have nitric acid. So this is not one that I would give on a test, but never hurts to push yourself just a little bit. Nitric acid is HNO3. Our H is going to be that +1. Our nitrate will be that -1. So it's basically nitrate with a hydrogen on the front end. So in this case, we have Pb plus HNO3. Next step is to check our activity series. So lead is on its own. It needs to be higher up on the activity series than hydrogen. Here is our lead. It is, just slightly, but it is. Therefore, the reaction will take place. So my lead and my hydrogen will go ahead and switch. So my lead has a +2 charge, and it's now going to join up with the nitrate. So we have Pb and O3. But since nitrate only has a -1 charge, I am going to need 2 of those to balance out the +2 of the lead. And now hydrogen is going to be on its own. And since hydrogen is on its own, it does need that subscript there. So now that we've got all of that done, let's go ahead and balance it. We've got 1 lead here, 1 lead here, 1 hydrogen here, 2 hydrogens here. So we need to balance this side. We also have 2 nitrates on this side and only 1 on this side. So by adding a coefficient here, we solve that problem, and now the reaction is balanced. So let's go ahead and do the last one of our first video, and that is gold plus hydrochloric acid. Now this particular worksheet does not specify which gold to use. Golds can be a 1 or a 2. So regardless of which one you did it as would be fine. I'm just going to go ahead and call this a plus 1. So we'll use gold 1. Hydrochloric acid, remember we've got it up here. That hydrogen is a plus 1, that chlorine is a minus 1. So here we can go ahead and write out gold is Au plus hydrochloric acid, HCl, and we'll go ahead and do that there. So let's check on our sheet. Here's hydrogen and here's gold. So remember, the element that wants to kick out the other element, so the freestanding one that wants to change places, does need to be higher on the activity series, and gold is the bottom of our current activity series, so definitely no reaction is going to take place. Hydrogen is much higher, so we are not going to have a reaction here. So this would actually be no reaction. So that does it for the first half of this. For those of you who may have walked out of class a little bit confused, I do hope that this video does help, at least watching me walk through it with explanations a couple of times. Hopefully that clears some stuff up. If there is still something that you are unsure about, please feel free to let me know. I have a meeting tomorrow after school, but I will be available before school. I hope you guys are watching this, and I do hope this helps. Have a wonderful night. I will be back with part 2 here shortly, and we'll continue on.